right, welcome back, students. Today we are on the last section we are going to do for chapter 3. So we're actually going to explore intercept form. But first, a little reminder of what we've done. So first off, we've figured out parabolas in standard form, which is y equals a squared ax squared plus bx plus c. So we've explored that. Okay. We've also explored vertex form. Vertex form was where it was written in y equals a times x minus h squared plus k, where the vertex hk equals the vertex. But today we are going to explore the intercept form. And the intercept form tells us where the x-intercepts are. It tells us where the x-intercepts are. So y equals a times x minus p, x minus q. And these are x-intercepts. So our x-intercepts are p0 and q0 equal the x-intercepts equal the x-intercepts. And don't forget, when there's a negative here, that means whatever number is here, it's the opposite, is the h. So if this were written y equals a times x minus 2, x plus 4, our x-intercepts are going to be 2, 0, and negative 4, 0. So keep in mind there's that little opposite thing. When the equation has a negative in the equation, it means that the actual letter, the number, is the opposite. So just keep that in mind. But here's your basics. You have the standard form. We figured out parabolas with the standard form by figuring out the axis of symmetry, right? We found the axis of symmetry when we used the negative b over 2a. And once we found the axis of symmetry, we can find the vertex, right? The vertex form, well, we found the vertex straight away, right? Because we know that it moves, right? Left and right and up and down. And then the intercept form we're going to explore today, and it just shows us where the x-intercepts are. If we know where the x-intercepts are, we'll be able to find the axis of symmetry because that's right down the middle of the x-intercepts. So if we can get it written in this intercept form, we'll know a lot about our equation, about our parabola. So here we go. We're just going to get straight into it. So we're on page 97. And here we go. Find the x-intercepts and the axis of symmetry of this graph. So our x-intercepts for this graph are negative 2, 0, and 4, 0. There's our x-intercepts. Now, for me, it's way easier to graph it so that I could do some counting and find the axis of symmetry, because the axis of symmetry is just directly in between, right? So let's put this right here. So we'll say here's our, so we've got negative 2, 0, and then we've got 4. So our axis of symmetry is right in the middle of these two. So we've got 1, 2, 3, 4, 5, 6. So 1, 2, 3. So here is our axis of symmetry. So it wants us to find our x-intercepts and our axis of symmetry. Axis of symmetry is x equals 1. Okay, so there we go. We were able to use that intercept form to quickly find our x-intercepts and our axis of symmetry. Now, this is a positive, so it's going to go up if we want to find our vertex. Do we want to find our vertex? Let's go for it. So if our x equals 1, let's plug 1 into here. So we have y equals 1 plus 2 times 1 minus 4. So we have 3 times negative 3. So we have y equals negative 9. So our vertex is 1, negative 9. So it's down here, and then it goes up like that. So there you go. Intercepts, axis of symmetry. Now this is going to want us to do all that, so we're going to graph it. We're going to label the vertex, the axis of symmetry, and the x-intercepts. So let's do our x-intercepts before we do our line. So our x-intercepts are going to be negative 5, 0, and then negative 1, 0. Now, if that doesn't make sense, you know what you can do is you can always take this and do our old favorite 0 equals x plus 5 and x plus 1. If you make either of these equal to 0, x plus 5 equals 0, you get x equals negative 5. Hey, look, see, there it is. And then if you make this equal to 0, you get x equals negative 1. So if that helps it to make sense, by all means use that. All right, so since we're in the negative zone, I'm going to move my equation over a little bit. And we've got negative 5, 0, 1, 2, 3, 4, 5, negative 1, 0. So our axis of symmetry, 1, 2, 3, 4. Our axis of symmetry is right here. So axis of symmetry, x equals 1, 2, 3, negative 3. And then we need our vertex. So I'm going to plug my negative 3 into this equation. So I have negative 3 plus 5 times negative 3 plus 1. So negative 3 plus 5 is 2. Negative 3 plus 1 is negative 2. So I have negative 4. So it's on this axis of symmetry. The vertex is on our axis of symmetry, and it's negative 4. So there is our vertex. Let's see. There it is. That's all we have to do. There's our parabola. And now we have to say our domain is all real numbers, and our range is y is greater than or equal to negative 4. Okay, so there's a couple steps, but I think if you can wrap your head around the x-intercept, the axis of symmetry being straight in the middle of the x-intercept, and then plugging in the axis of symmetry is going to give us our vertex. All right, let's try it again. Go ahead and pause, try number 4 on your own, and then we'll get the rest. Now this, for number 4, don't forget, a negative, what does that mean? Ooh, a negative, that means it's a frowny face. It's a frowny face. So don't forget, negatives, frowny faces, positives, smiley faces. And you'll be able to find out because your vertex will be above your x-intercepts for a frowny face, and your vertex will be below your x-intercepts on a happy face. All right. Now this one, if you notice, is not written in our intercept form. But if you do notice, it's a perfect square minus a perfect square. Now, a perfect square minus a perfect square, we can factor to be x plus 2, x minus 2, right? The square of x squared is x. Square of 4 is 2. So it's a plus 2 minus 2 if we have two perfect squares that are subtracted, x plus 2, x minus 2. So there we have our y-intercepts. We have, for here, we have negative 2, 0, x-intercepts, not y, x-intercepts. And here we have positive 2, 0, right? It's always the opposite of what's in here. So there's our intercepts. So I'm going to go ahead and put this, it's a happy face, so I'll put this right here. Let's put it straight in the middle because we have this straight in the middle. So negative 2, 0, and 2, 0. And now how do we find where is our axis of symmetry? 1, 2, 1, 2. It's right in the middle. So our axis of symmetry is 0. Axis of symmetry, x equals 0. So let's plug a 0 into here. So I have 0 squared minus 4. So I have negative 4. 1, 2, 3, 4. So there it is. It is a positive, so I am doing a happy face. There we go. So now we have our parabola drawn. We've got our x-intercepts. We've got our axis of symmetry. X-intercepts, axis of symmetry. I should put boxes around all of our answers. Okay, axis of symmetry, x-intercepts, and our vertex. Vertex is 0, negative 4, and our domain and our range. Our domain is all real numbers, and our range is y is greater than or equal to negative 4. Okay, now this one, it's written in standard form, right? It's written just like this. It's written in standard form. So you can find your axis of symmetry if you want, or what you can do, since this is in the intercept form section, you will be able to factor this, find the factors of negative 15 that add up to 2. Don't forget, find the factors of negative 15 that add up to 2. And you'll be able to get it. Then you'll have your intercept form, write an intercept form, get your axis of symmetry, plug your axis of symmetry into here, and then you'll have your vertex, which will allow you to do your range, your domain, and your range. All right, let's look at a couple more. So, number 7, find the zeros of the function. So the zeros, what are the zeros? That's our intercept. So let's find the zeros. So for this one, let's go ahead and do, so we're going to make it equal to 0 because we're going to find our zeros. I'm going to factor out a 6, and I'm left with x squared minus 1. Hey, look at that. That gives us a perfect square minus a perfect square. So a perfect square minus a perfect square would be x plus 1, x minus 1. And I had to make sure I had the 6. Now it's actually written in intercept form. So my zeros are negative 1 and 1. You might be saying, no, Blue, that's a positive 1. No, remember, if I make x plus 1 equals 0, I have to subtract 1 from both sides, and I end up getting a negative 1. All right, now this one, same as here. You can factor it out, and you can get it into intercept form. So number 8, you'll be able to factor this out and get it into intercept form. So get your factors of 20 that can add up to 9. Okay, pause it, finish that. Let's go on to number 9. Use zeros to graph the function. Okay, great. Here's a trinomial, just like we had. And we're going to, I'm going to factor this. So I need to get the factors of negative 10. So I got 1, 10, 2, and 5. And I need it to get to a negative 10. So one of these is going to be negative, one is positive. I know negative 5 plus 2 is negative 3. So x minus 5, x plus 2. So there I have it. So what that tells me is my x-intercepts are going to be 5 and negative 2. So 5, 0, negative 2, 0. So there's my intercepts. So make this not exactly centered because I know I have, oh, that's a 5. Oh, I made it uncentered the wrong way. Anyways, 1, 2, 3, 4, 5. 1, 2. So I have 1, 2, 3, 4, 5, 6, 7. Ooh, they gave us an uneven one. So 1, 2, 3, 1, 2, wait, what? 1, 2, 3. So here our axis of symmetry is right in the middle here. So our axis of symmetry is going to be x equals 1.5. 1.5. Why did they give us a one like that? Okay, so let's plug the 1.5 back into here. This is going to be easier than this. So we have 1.5 minus 5 times 1.5 plus 2. 1.5 minus 5 will be negative 3.5 times 3.5. So we have negative 9, 10.5. Let's just make sure. 3.5. Oh, 12.25. So we have negative 12.25. So we have 1.5, negative 12.25. You know what? Let me pause, make sure I'm giving you the right answers, and I will be right back. Give me a second. All right, I'm back. It is correct. I wish I had done it beforehand so I could have moved this way up, but 1.5, negative 12.5. So way down here. It's going to look something like that. And there's our function. And if you end up going off your graph, just label these points. So I know that you know what you're doing. Okay. Last one. Number 11. Excuse me. Perfect square minus perfect square. Great. We've done several of these. So it's the square root of that plus the square root of that, square root of that minus the square root of that. So I've got an x and a 3. So I've got x plus 3, x minus 3. So, you know what? Just to keep these separate, I want to say use ink so that you can see the difference or see the different problems. So here I have negative 3, 0 is one intercept, and then I have 3, 0 is another x-intercept. So, and it's a positive, so it's going to go up. So let's just, I'm getting these kind of wrong. So I'm just going to go straight in the middle. 1, 2, 3, 0, 1, 2, 3, 0. And that means that my axis of symmetry is right there in the middle. So I have 0. So I have 0, axis of symmetry, x equals 0. So I plug a 0 in, 0 minus 9. So my vertex is going to be 0, negative 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And again, if you're off the chart, go ahead and write 0, negative 9. And then, oh, you know what I could have done? I could have just made each of these worth 2. Well, live and learn, right? If I made each worth 2, I could have labeled it 2, 4, 6, 8. I would have had it right here. It would have been perfect. Okay, use zeros to graph the function. That's it. I just graphed the function. There it is. What's my domain? My domain is all real numbers. My range, x is greater than or equal to negative 9. There you have it. All right. Ask me any questions you have, and have